questions or just in general for you guys to work on things. I guess before we release you to work on whatever you need to, are there questions either general or specific? So while you guys are looking or thinking here, because it looks like some of you guys are doing that, I'll talk a little bit about the test format once again. So I've divided the test into two parts. The first part is tomorrow. That part's focus is going to be on kind of the shorter, more computational questions. So if you locate the test on the PowerSchool calendar and you look at the assignment, I have a list of kind of things that you should be able to do. So there's a bullet pointed list there on PowerSchool of things that kind of topics I think are worth reviewing for the part one of the test. And then if you look at the second part of the test, you can see, again, the kinds of things that'll be there. Most of the, all the lengthier questions are things that'll appear on the second part of the test, and there's only 6 of them. So you have 70 minutes to do 6 problems or whatever, which is probably realistic considering some of them are, again, in a test setting, kind of lengthy things to ask you to do. The things in the first part should be much quicker. Everybody okay with the format? Okay, Michael?
Are we going to be given any equations?
So you notice at the last page of the review, I have 2 formulas listed at the very end for the angle between 2 vectors and the projection of one vector onto another.
Yeah.
Those 2 formulas you'll be provided.
Right.
That's it, though.
Okay.
Anjali? Sure. So Anjali asks an example of finding the angle between 2 vectors. So what I'm going to do is I'm going to do number 35 from the homework, which is that question. So we're given that vector u is 3, -8, and vector v is -4, 5. So the formula I'm going to use is the angle between 2 vectors, which is the dot product of uv divided by the magnitude of u times the magnitude of u. So that's the formula that I'm going to be using. Again, that was one of the formulas that will appear on your test. So that's not something you need to memorize, but you do need to know how to use it. So we'll start by just computing the dot product. So to do the dot product, I multiply the x coordinates together, and then I multiply the y coordinates together and then add them up. To calculate the magnitude of a vector, that's the x coordinate squared plus the y coordinate squared, all square rooted. That's something that I would expect that you guys have memorized. So that is the square root of 9 plus 64, or square root of 73. Likewise, the magnitude of v is the x coordinate squared plus the y coordinate squared. So in this case, that's 16 plus 25, or 41. So I can say then theta is equal to the cosine inverse of -52 over square root 73 times square root 41. And I'll just type that into my calculator now. So cosine inverse, and then I like to use the fraction option here to write this as a fraction. Makes it a little bit easier not to goof up the parentheses. I can retrieve that fraction option by pressing alpha on the y equals button and selecting the first option from the menu. You don't need to do that, but I like to do it because it makes it easier than making sure that I have the parentheses in the right places. But you don't have to. So when I do that, I get 161.9-ish degrees. Is there a way that you can kind of check to see if that's a reasonable answer? Yeah. What if I just graph these two vectors? So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So there's U. And then 1, 2, 3, 4. 1, 2, 3, 4, 5. So there's V. And the angle between them is going to be the smaller of the two directions. So that looks 160-ish is not unreasonable for that kind of an answer, right? If I look at that, that's close to being straight, which is 180 degrees. So that's probably a good answer. Now that's not a super specific check, but it's a nice like intuitive check because it's easy to do. It's quick. You know, if you're really wrong, you'll definitely get a good idea that you're really wrong. Does that feel good? Of course. Are there other specific questions that you guys have? Happy to do more, but if you just need time to like work on your stuff, I get it too. We don't have to sit here and do it the whole time. Michael?
You got another 3D vector.
Yeah. So we just want to graph a 3D vector. So let's say we do like number 88 from the homework. That's a graphing a 3D vector problem. Does that work for you, Michael?
Yes.
All right. So I have my XY axis here. So 88 is the vector 4, -5, -6. So I'm going to start by putting some tick marks. So 1, 2, 3, 4 on the positive x-axis. 1, 2, 3, 4, 5 on the negative y-axis. And then 1, 2, 3, 4, 5, 6 on the negative z-axis. What I like to do then is I like to start on the x-axis at the last tick mark I made, and I'm going to just draw a line that's basically parallel to the y-axis. I'm then going to move to the y-axis, and I'm going to draw a line that's parallel to the x-axis. So that makes like the bottom of my box. Okay with that, Michael? And if I was graphing this in 2 dimensions, this would be the point that I'd be concerned, right? What I'm going to do now is I'm going to extend this into 3 dimensions. So I'm going to start at the origin, and I'm going to graph down to that last point on the z-axis. I'm then going to move over to the other point on the y-axis, and again graph down that same 5 units. And then I'm going to go to the other points and then estimate down about 5 units in each of their cases. And then I'm just going to draw the rest of my, or connect those to make the rest of my box. So the point that I care about in 3 dimensions is the one that's connected to the point I cared about in 2 dimensions. So there's my point that I care about right there. Actually, let's use, oh boy. Let's use a different color, huh? Maybe I'll make that green. So then to draw the vector, that's the last thing I need to do. I'm just going to draw an arrow going from the origin to that point. Okay? You're welcome. And again, on the test or whatever, I would expect to see the box kind of built. When you're graphing one of these things, it gives you or gives the reader anyways, a much clearer picture of like where in space that is. Anyone else questions? Anjali? Yeah. Yeah. So I started here by drawing from the x parallel with the y. And then I moved to the x and I drew, or I moved to the y and then I drew parallel to the x. And that makes my box then. Right, so that's going to give me this. And then I go starting at the origin and I graph down along the z-axis. And then I continue graphing in the z direction from each of the other three vertices. That about the same amount. I'm just kind of eyeballing the length there. And then I can connect them all together. Is that what you needed? Yeah. I mean, if, again, once we're going to be done, I think, with questions here in just a moment, if you wanted to try to do something and have me look at it or work through one where I can kind of let you write and kind of we talk about it, then I'm happy to do that. Okay? Leonie? So the different forms is what I mean there. So like this is an example of maybe an IB component form for a line. If we wrote this as a component form, or say like a linear combination form, you should be able to just kind of be able to write your answer in a form that I'm requesting in the problem, or if I give you, some information, one form that's maybe not convenient, you're able to like convert it into a form that is convenient to work with, or able to pull the information out of the problem that you need, regardless of the form that I put it in. That's kind of what I mean. Is that okay there? So that's an example. There's three different forms there that I wrote that same line in. This is the IB. This is just component. This is linear combination. If you could say like, you can call it a slope-intercept form. Is also a line still. But that's I guess what I mean. Yeah, no problem. Okay, so let's stop here. If you decide that there is still